materials we'll need for the lab. We'll need 2 beakers, and then the scale we'll need for measuring the sodium hydroxide pellets. The 2 burettes we'll need for one to hold the sodium hydroxide and the other to hold the hydrochloric acid. The pH indicator, we're going to put a few drops into the acid as we add the base. And the stir rods, we'll need those to stir it as the base is being added. And the ring stands is to hold the whole contraption.
So for our procedure, first of all you're going to gather your materials, and second you're going to make the base, which is NaOH, and it's going to be 100 milliliters of 0.5 molar base. And third step is to prepare the titration. And number 4, you're going to measure out the 10 milliliters of acid, which is the HCl. In step 5, you're going to add 3 drops of pH indicator. And number 6, you're going to titrate 4 times. And number 7, you're going to record and solve for molarity M of acid.
So our first step for the titration of this experiment to find the molarity of the acid is to make our base. So right now Sky is measuring out 1.9 grams of sodium hydroxide. We are determining the molarity and the volume of the base that we want, and we'll be adding to the acid. And in the acid we'll know the volume of it but not the molarity. So we'll use proportions and cross multiplying to solve algebraically. So do we just about have it, Sky? 1.9 grams? Alright, that's the first step. Alright, so step 2 is we will be taking our 1.9 grams of sodium hydroxide, and we want to make 100 milliliters or 0.1 liters of our base solution. So what I'm going to do is I'm going to add this until it hits the 100 milliliter mark down here. See here?
We need the acid.
Yeah, that's about right. Now I'm going to mix for the chemical reaction. This is an exothermic reaction, so energy is given off. And these sodium hydroxide pellets should react with the water and create our base. So what we did before we started titrating is we cleaned these out to make sure there's no more chemicals. We have 2 burettes right here. One is going to be for the base. It's going to titrate, and we're going to measure out how much is added. So we'll know the molarity of what's going in, we'll know how much goes in, and then we'll know the volume of the acid that we have, and that's how we'll do the math, because it'll turn pink because of the indicator that's in there. We'll know when it reaches that 7 pH equilibrium. And then we'll cross multiply and use proportions and algebra to find out the molarity of the acid. On this one, this burette right here, we're just using to measure out 10 milliliters of the acid accurately. So that's step number 4. So this is the data that we recorded with our 4 titrations. We created a data table for 1, 2, 3, and 4. Going into this lab, we had 3 controls. We knew the molarity of the base that we created. We knew the volume. We measured the volume of the base that we added to the acid during titration. And we were also able to control how much acid that we had in the cup that we were titrating. Now using this chemistry equation right here, we know that the molarity of the base times the volume of the base should equal the molarity of the acid times the volume of the acid. So having these three controls we can solve algebraically. So I'm going to do trial 1 first, and I'll do it right down here on the board. So using MB, VB equals MA, VA, I can divide both sides by the volume of the acid that I had so that I've isolated the unknown variable. So the molarity of the acid should equal the molarity of the base times the volume of the base all over the volume of the acid. So if you come over here, I'll put that into practical terms with the numbers that we have in our data table. So we have a 0.5 molarity of the base. We use 15.6 milliliters of the base. And we also had 10 milliliters of the acid. Sorry that's a little messy. I need a calculator. So when I solve this out, I know that the molarity of the acid is equal to 0.78. And now I will repeat this for all 4 of our trials. So after doing our titration lab and solving for the molarity of the acid, for precision we averaged all 4 of our trials. So I took the total sum of the molarity values, all 4 of these, and I divided by the number of values I plugged into the equation. Look down here. I took the value of the molarity found in each of our trials, and I divided by the number of 4 because we have 4 values. After doing that, we found that the average molarity of the acid was 0.7 molar. And we did this because 4 trials is more precise than just 1.